For this question, we want to find the critical points of this function. Perhaps there are some, or maybe some don't exist. But a critical point is defined as any location where the derivative of your function is equal to 0. So essentially, we want to solve this equation. For starters, we have to take the derivative of f of x. All right, so f of x, I'll just rewrite the function as x squared, and maybe I'll put x plus 6 to the 1/2 power. I'm writing it this way, so I can use the product rule to find f prime of x. The derivative of a product is, well, we take the derivative of the first, which is 2x, and then we multiply that by, just copy down the second thing. Okay, then you add, we reverse this. We copy down the first, but then take the derivative of the second piece. The 1/2 comes down front. We copy down x plus 6. We subtract 1 from the exponent and multiply by the derivative of the inside function. Altogether, that is, all right, we bring down the half, copy down x plus 6. If you subtract 1 from a half, you get negative 1/2. And the derivative of the inside part is equal to 1, which you don't have to write. So this thing represents your derivative. I think if you want to solve where this thing is equal to 0, it would be a good idea to simplify this expression. And that's what I'm going to do next. So to start with, I won't copy down the f prime of x. I'm merely just going to simplify this and set it equal to 0 and hopefully solve for x. All right, so that is 2x times x plus 6 to the 1/2 power. And we'll add on. Okay, here we have an x squared. And this negative exponent means you can take this expression and put it in the denominator next to this 2. So that's what I'm going to do next. I have 2 is already in the denominator, but I'll put x plus 6 to the positive 1/2 in the denominator as well. All right, I'm going to set this equal to 0. Let's see, a couple of ways we could go about this. We could, subtract this to the other side and try to cancel any like terms. You could also try to make this one fraction, and I think I'm going to take that approach. We need a common denominator, and that least common denominator is going to be 2 times x plus 6 to the 1/2 power. And what we're going to do is write this first part as a fraction, and we're going to multiply this to the top and to the bottom, giving us the same denominator. So when I take this and multiply it here, I'll have 2 times 2. That gives me 4. I'll have x, but I'll also have x plus 6 to the 1/2 times x plus 6 to the 1/2. You would add those two exponents, 1/2 plus 1/2, giving us an exponent of 1. And I'm just not going to write it. So here we just adjusted the first fraction by multiplying the top and bottom by 2 times x plus 6 to the 1/2. We're then going to add that to our other fraction, and because we have a common denominator, we can add these numerators together, and I'll put that on the next slide. So here's the net result if we add the two fractions together. And I suppose I'll simplify the numerator. So, I'll distribute in the 4x and add it to the x squared and leave the denominator completely alone. So if I multiply this in, what do we get? We have 4x squared plus 24x plus x squared, all divided by 2 times x plus 6 to the 1/2 is equal to 0. And here we have a couple of x squared terms that can be combined. We have 1 and 4, so that means 5x squared plus 24x all over 2 times x plus 6 to the 1/2 is 0. We want to solve this equation. The nice thing is, if you're saying a fraction is equal to 0, you can just look at the numerator. Wherever your numerator is 0 will make the whole fraction 0. This kind of simplifies this for us. We only need to solve this equation. Where does this happen? A couple of ways you could go about this. I think I'm going to take a factoring approach where I see I can factor x, a single x out from both terms. And what is left over is 5x and then plus 24. Because now I can look, because we're set equal to 0, I can look at each individual factor and see where it is equal to 0. So that is x is equal to 0, but also where 5x plus 24 is equal to 0. And like instantly, this gives us one of the solutions. X equals 0 is a critical value. But if we also look at this 5x plus 24, you'll subtract 24 from both sides. You'll divide both sides by 5. And this is the other critical value. MyLab asks that when you enter this, you just write both solutions and separate them with a comma, but these are the two solutions for the critical values of the original equation.